All right, let's solve some exponential equations today. So there's going to be two types we're going to talk about. The first one is when we have the same base. So a typical problem might look like 2 to the third equals 2 to the third. Well, hopefully we agree that 2 to the third equals 2 to the third. But let's make this a little more challenging. What if it's 2 to the x equals 2 to the third? Now, what's x equal? Remember we said the other day, if the bases are equal, then the exponents are equal. So in this case, we can go off and say x equals 3. Well, let's just make it slightly more challenging than that. Let's pull off 3 to the raised to the exponent of 2x plus 1 equals 3 to the 15th power. So 3 to the 15th power is a big number, and we've got a variable in the exponent position, and that's just not very good. But notice we have a common base of 3. So if the bases are equal, then the exponents are equal. So now I can just make a new equation that's equivalent, and it has the same answer. 2x plus 1 equals 15. That's just a two-step equation. We can handle that rather easily. Subtract the 1 from both sides. That would leave us with 2x equals 15. Oops, 14. It's Monday morning. 14. And then we're going to divide both sides by 2. So now x equals 2. Now, always check things on your calculator. Let's go back to our original equation. 3 raised to the exponent. It's 2 times our answer, and our answer was 2, plus 1. That equals 243. And 3 raised to the 15th power. Okay, so I made a mistake somewhere. Okay, because it's not 2. 14 divided by 2 is 7. Boy, it is Monday morning, isn't it? But that's why we check our solutions, because even math teachers make mistakes. So now let's try that check again. 3 raised 2 times our answer of 7 plus 1 equals, that looks a lot better. That's now the right side is 3 raised to the 15th power. Now, those two numbers are the same, so I'm good. Boy, drink a little more coffee Monday morning. Be careful, even math teachers make mistakes. That's why we always check our solutions. Now, let's try one that's just a little bit more difficult along the same lines. Where let's say we had 2 to the 3x equals 8 to the 4th power. You're like, hey Whitley, those aren't the same base. They're not the same base, but they could be. So if we see this, we see 2 to the 3x. Well, 8 is 2 to the 3rd power. Now, I'm just going to replace that 8 with a 2 to the 3rd power. Now, we have some exponential properties here. Power of a power, what do? So we're going to leave 2 to the 3x on the left, and then the right's going to be 2. Now 3 times 4, that's the power of a power. You multiply the exponents. That's going to go to the 12th. So now I have the same bases. So if my bases are the same, my exponents will be equal also. That's going to be 3x equals 12. And that's a much easier problem to contend with. Just dividing both sides by 3. I can say my answer is x is going to equal 4. Now, since we've had a lack of coffee this morning, let's go ahead and check. So 2 raised to the exponent of 3 times our answer of 4. That's going to equal 4,096, and 8 raised to the 4th power is 4,096. So I'm good. So that's the first style you will see. The biggest problem is we have a variable in the exponent position. One way to get rid of that is to make a common base, and then once we have the common base, we say The bases are equal, therefore the exponents are equal. And we can make a new equation with just the exponents, the 3x plus 12. Solve that, and it's nice and easy. Now, what happens when the bases are not the same? So we'll say base is not the same. And there's no way to make them the same. Sometimes you get lucky, you can make them the same. So let's just say we have 8x equals 92. Well, 8, I can change that base to a 2, but I don't know what I would do to, what base I could change to get to 92. Well, remember our log base thing in the calculator? Let's just translate or transform this exponential equation into log form. So the first thing we're going to do is write log. The base is going to stay 8. Now we're going to write the 92, so log base 8 of 92 is going to equal x. Well, hey, x is what I wanted to know. I can do log base, I can do that in the calculator. So let's just put x on the left because that's where I like it. Let's pull out the calculator. We're going to go second, y equals. We're going to hit the function tab, go down to number 5, log base 8 of 92. It is typical to take these to 4 decimal places, 2.1745. Well, let's just check this. Now, I did just round that number, so we should be pretty darn close, but it might be off by just a touch. So we're going to have 8 raised to the exponent of x, but our x is 2.1745. That's 91.996. That's very, very close to 92. I'm going to call that good. The difference would be a rounding error. Now, does an answer around 2 make sense to you? Sometimes what I do when I kind of doing this backwards, but I sort of estimate the answer. If you go, let's clear and clear. If I go 8 raised to the x, and I go to my table of values, so these are all the bases of 8, and this is raised. Apparently I better hurry up. So 8 to the first power is 64, 8 to the second, 8 to the first power is 8, 8 to the second power is 64, 8 to the third power is 512. 92 is between that 64 and that 512, so I think I'm pretty good. So let's just look at this because I'm running out of time. When the bases are not the same, I translated the exponential equation into a log form and used my log base function on my calculator to finish. So, excellent job. Have fun.